Hello, everyone, and thanks for joining our session here at the Open Source Data Summit. Our session today is called Open Data Foundations with OneTable. I'm Tim. I'm a software engineer over at Onehouse. I'm joined here with two great co-contributors to the project and the vision of OneTable. Do you want to introduce yourself, guys?
Hello, everyone. My name is Ashvin Agrawal. I am a senior researcher at Gray Systems Lab in Microsoft.
Hello, everyone. My name is Anoop Johnson. I'm a software engineer at Google working on BigQuery.
All right, so to kick things off, I think we need to start from like kind of shared understanding of what are these table formats? And at their core, these formats are really just grid abstractions that allow us to think about large sets of data like tables. We can do inserts, updates, deletes, manage the tables, and really just make our lives a lot easier when dealing with this data at scale. So um, there's three main players in this space right now, but when you think about it at rest, when these tables are just existing in your S3 bucket or GCS or your Azure account, they're not all that different. They're metadata in a set of parquet files or whatever other format you're using to store that data. So with that in mind, the OneTable project is really just this omni-directional interop for the table formats. It's a lightweight translation layer of this metadata that allows us to, fundamentally read the tables as any format and work with any sort of tools that maybe require a certain format. The project itself is not a separate, table format. It's not adding any new metadata. It's just building on top of what's already present there by these three existing projects. So, why even build OneTable? The cost of choosing a table format really comes down to like how long you spend thinking about it, right? So there's a lot of engineering decisions that have to be made when you're building out your data lake. And a lot of time can be spent tinkering with different formats, trying to understand the features that exist in each of these formats that fit your use cases best. Could be possible that one format's not going to fit every use case, since each of these projects has unique features that are very powerful and helpful for different use cases. And maybe there are also vendors that you're considering using that only support one of these three formats. You don't want to be laying awake at night wondering what life would have been like if you had just chosen the other format. So with that, we present OneTable, which helps you write once and query everywhere. Really helps remove the decision-making part of this, and that you can just use a single writer and expose the table as different formats and work with them in those different formats. So with that, we'll do a demo highlighting the capabilities of OneTable. But first, I guess we'll quickly walk through this flowchart here. It's also available on our GitHub repo, which is recently public. It's open source, and you can check it out there if you want to look more in detail or ask questions. You can file issues on GitHub as well. So to kick things off, we have the sync process, and there's two modes that can be used when running a OneTable sync. There's incremental mode, and there's a snapshot or like full sync mode. So the incremental mode is really just is more lightweight, and what we try to run with what we run with in at Onehouse in production. So when you first start this process, you'll check if the user has one enabled incremental sync, and then two, check if it's even possible to run that incremental sync. So for example, if there's no previous sync run, then you'll need to fall back to just the full sync to kick things off, to get you, build up that initial state. Or it's possible that things have fallen out of sync or some other issues, in which case we'll automatically fall back to the snapshot sync for you. Now, these two processes, these two paths that will go down, you'll see they're really only differ at this extract from source stage. So like I said, in the incremental mode, it's more lightweight. We're just going to look at the commit metadata that's changed since the last time the sync ran. And we'll pull out all of the files that are added and dropped, any schema changes, etc. Whereas in the snapshot case, we're just going to pull the entire view of the table and then later diff that against the target tables to see what's changed. So incremental process is a lot more lightweight, making it a bit faster, a bit more memory efficient, the preferred mode of execution. Once we get down here into the target sync mode, we'll see that they're not that different between the two. We can kind of just generalize it into one flow where we start a sync, we start a transaction, for example, in Iceberg or in Delta Lake or Hudi. Then we sync the schema, partition spec, the files that have changed, and some metadata, including the commit time that was we've last synced in the source. So that way the next round we can run that incremental sync if we want to. And then we'll close out the transaction. And then after that, you can use your tables as though they were written by that target format. So with that flow in mind, we'll start out with kind of a silly demo example. I've already created two tables. One of them is written in Hudi and one of them in Delta Lake. And now just imagine also, for whatever silly reason, there's some team that decided they strictly want to work with Trino and Iceberg tables. So just for fun, we're going to set that up as well. So here, what we're going to start off by doing is have this Hudi table, and we're going to sync it to Iceberg. So we'll specify some options, including the Iceberg catalog and the target format. So we have some Hudi table name where we started, the base path, target, and now you'll see that this outputs the sync result here. We were successful. It fell back to that full sync, even though we would configure it incremental because it is the first round. So to show off that that incremental sync can happen, we'll write some more data to Hudi, and then we'll once again sync it to that Iceberg metadata. So here you can see that the sync result is showing up as incremental. And now comes this team that, this made up team that said, I need to add a single row and I need to use Trino. But there's only one problem with that. Like Hudi and Trino, there's no write support from Trino to Hudi. So that's kind of a problem. But due to OneTable, this is really also an Iceberg table. So like now we can just write to it via Trino and Iceberg. So here what we'll do is we'll just quickly, I have Trino running in the background in Docker, and I'll probably share this whole Docker setup as well in a branch off the repo. We'll execute an insert into this table. I'll let that run. And then just for fun, to kind of show off, all the different edges of this triangle of conversion, if you will, we're going to say that we're going to start with the Iceberg table that we just updated as a source, and we'll sync it to Delta. Maybe in the end, we'll just work with all of the tables as Delta. So we'll run this sync, and then shortly after, we'll read back that table and just show that the entry that we wrote up above is in fact reflected into the table. You can see it there. We've added this new entry. And to close out the last edge of this triangle, we'll just show that we can take that existing Delta table I mentioned at the very beginning of the demo and write it as a Hudi table. So we'll set up a sync similar to the one that we had before, but this time the target table format is Hudi. You can see we can read it from Spark with format Hudi. We have some options here. We have to use the metadata table from Hudi, but other than that, pretty easy to load. And then just for fun, we'll expose both these data sets as Delta tables. Maybe you wanted to use some of the processing powers in Fabric or Databricks' Photon engine and needed those tables to be exposed as Delta. So you can see here that we went from a Hudi table, incrementally updated it into an Iceberg table, wrote from Trino back to the Iceberg table, and then ended up exposing it as a Delta table, just so we could join it here with this original Delta table. It's a bit silly of an example, but just kind of showing you all the different possibilities and hopefully inspiring some cool ideas in the audience. All right, so Ashvin, I want to hand this over to you.
Thank you, Tim. This was a fantastic demo. Iceberg capabilities are really impressive. It can generate table metadata for any table format, and it is done efficiently. And this opens up so many possibilities. Let me share my screen here now. Okay, so what Tim just showed were impressive capabilities of the OneTable library. I'm Ashvin, I'm from GSL Research Lab, and our research shows that not only the use of multiple data formats in business use cases is pervasive, that is, tables can exist in Delta format, Iceberg format, or or Hudi format, but even confining the data estate to one data lake itself is a big problem. Data estate is often sprinkled across multiple data lakes. And with the next demo, what I'll do is I'll take Tim's demo to the next step, and we'll show the capabilities of Fabric together with some of the capabilities of OneTable, which presents users with the ability to see a unified logical data lake in which users are able to get data from multiple storage formats and from multiple data lakes, and then query on top of it for data analysis and generating useful insights. So what I've done here is that I have a Fabric instance, and I have these two demo data lakes. One is the geo data lake and one is the sales data lake. The geo data lake has the same tables which Tim was showing earlier in his demo. And we know that for these tables, the table Iceberg and all the three table formats exist for both these tables. Similarly, for the sales data lake, I have the Delta format generated from the Iceberg table, and which means that sales table can also be read wide in Delta format. Fabric today supports reading tables which are in Delta format, which means that now my data estate, which is in two data lakes and in three different tables, which were originally created in three different formats, now have a Delta view, and Fabric can present a unified view on top of it. With that, I'll jump into the demo. And so in Fabric, as I mentioned earlier, that I had created access, I had authorizations to access these two data lakes. And now in Fabric, I can see that I have a Delta table, a Hudi table, and an Iceberg table, and I can select any location and I can create a shortcut to this particular location. What this will do is that if there is a Delta representation for a table available in this location, Fabric can start providing users with the ability of reading this data. Because I've already added this in Fabric, I'll skip the creating the shortcut. Here you can see there are three different tables. There's a Delta table, Hudi table, and the Iceberg table. Now, if you see that the boundaries of different table formats, and the boundaries of different table lakes have disappeared. This data estate will be managed uniformly. There'll be unified governance experience on top of this data experience, thanks to OneTable that we can see everything in Delta format, and thanks to Fabric, there's unified experience. Users can obviously see what are the data in each of these tables. They can load the preview, and on top of this, now that we have the data available in Fabric, users can also define advanced relationship between these tables. So again, in my data estate, I have the Iceberg table, and if I can create these relationships, what it is showing is that the geography key in the sales territory is the same geography key. It can also be used as a join key for joining with the geography table, which was in Delta format earlier. And now that we have this unified experience, we have seen how queries, Tim was showing how queries can work on any of these tables and the notebook experience. We can do something different now. For that, I have created a demo scenario in which I have this Power BI dashboard. And let me create a map of where all the locations where this particular dummy company existed. So I create a map, and I can select the state province of my from my Delta table and add it. And I can see these are the different locations in Power BI where all my company operates. And then I want to see how many customers are in different areas. So the customer data, if you see here, was originally in Hudi format, which later on was converted into Delta by OneTable. And maybe I can select customer key, add it in one of the fields, and start counting them. So this particular visual will show me how many customers, say, are in California, and how many of them are male and female, and so on. And then finally, I also have the Iceberg table, which has sales information. And if you recall, this table was in a different data lake altogether. So I select another visual and I want to see in specific areas how many sales representatives are active. So maybe I can select one of these fields again from the sales table and I can aggregate by count. And what I see here is that in California, there are almost 2,400 customers, but there are no sales representatives. I select another state, say Texas, and here I have 3 customers, but there are 30 sales representatives. Now, what this shows the power of unifying data state and also the power of unifying the eliminating the data silos, which typically would exist in any business. And this is all coming together. And to take it even further, I'll invite Anoop to show how OneTable aligns with their vision at Google.
Thank you, Ashvin. I'll share my screen. This is Anoop from BigQuery team at Google. So just want to talk about how OneTable fits into the vision of Big Lake. Big Lake is an evolution of BigQuery that makes open data a first-class citizen in BigQuery. So Big Lake allows customers to keep their data in open file formats in cloud storage and do the analysis in BigQuery. So you get all the great features of BigQuery, such as materialized views, performance. We also have uniform fine-grained security for open data that extends to BigQuery as well as to open source query engines like Apache Spark. Big Lake Managed Tables is the next step function of Big Lake that brings read and write capabilities to Big Lake tables. So with Big Lake Managed Tables, the customer experience is very similar to BigQuery native tables. So if you observe the TDL as well as the DML is almost identical. So you would create the table using a create table statement as opposed to a create external table statement. So the user experience is very similar to BigQuery native tables with one difference, which is that instead of storing the data in BigQuery's internal columnar format, we store the data in the customer buckets as parquet. And the source of truth for a Big Lake Managed Table is big metadata, the state-of-the-art metadata system that BigQuery uses. So combining big metadata with open data allows Big Lake Managed Tables to provide state-of-the-art features that are typically present only in data warehouses. But openness of the metadata is also important. So which is why Big Lake Managed Tables export the metadata and big metadata into Iceberg snapshots. The exported Iceberg snapshots are registered with Big Lake Metastore, which is an Iceberg, which provides an Iceberg catalog implementation. So an open source query engine like Apache Spark, they can query this data directly as Iceberg tables. So open source engines, they have 2 ways to read a Big Lake Managed Tables. One of them is just reading it as an Iceberg table from GCS directly, right? So query engines would discover the Iceberg snapshots from Big Lake Metastore and then read the data directly as Iceberg tables using open source Iceberg libraries. The second way is to read them as a regular BigQuery table through the Big Lake storage APIs that we provide. And we also provide built-in connectors for engines like Spark. And Spark would read the data from the Big Lake storage APIs using the connectors. The advantage is you get a strong consistency, and you can also do fine-grained access controls because the users no longer have access to the files. This allows Big Lake to enforce row column level security, data masking, etc. So we envision OneTable as a way to extend this interoperability even further. Using OneTable, customers can convert the Iceberg snapshots that Big Lake Managed Tables generate into any table format of choice, including Hudi or Delta Lake. And this allows customers to be able to query Big Lake Managed Tables from anywhere, taking to the vision of OneTable. Just to recap, Big Lake Managed Tables is this new Big Lake feature that brings BigQuery storage features to open data. It supports DML, high throughput streaming ingestion, time travel, etc. Also, this is a fully managed service. It supports clustering and things like housekeeping of the data, combining smaller files into larger files for better performance, automatic background reclustering. All of this is kind of done under the hood automatically with BigQuery. And Big Lake Managed Tables provide Iceberg-compatible metadata, and the interoperability is extended through OneTable into any table format of choice. Back to you, Ashvin.
Thanks, Anoop. That's fantastic. And what we really see here is that how all these different solutions come together, and real practical use cases of data integration require multiple parties to come together. And that leads me to my next topic. Let me share my screen. So what are we doing with, what is our vision with OneTable? Our main goal is to build a seamless and efficient interoperability engine, so we can allow users to bring their own engine, bring their own table formats, or even have a use case where a hybrid scenario exists, multiple engines, multiple table formats, essentially eliminate those data silos so that the real value of data is always available to the users in a way which is provides them easy to learn, easy to ramp up, and easy to take it to market. But obviously this cannot work unless we have a project which is sustainable in this rapidly evolving domain of table formats, where new table formats are coming up, new features are coming up. We want to evolve with the table formats. And as of now, what we have done is we have started building real-time and transparent replication in any direction, which eliminates the need of investing into specific table format related readers and writers, or even converters, which is expensive, right? If we have one converter per table format, it is quite expensive to maintain in the infra with providing support for that and so on. In OneTable, we have invested heavily in building an accurate and a lossless model. It is a superset of all the features available. Internal representation is a superset of all the features available in the current table formats, so that whenever conversion happens, it is no information lost in the translation, and we are able to generate the maximum output in the output target. The design of one format is as Tim was sharing earlier, it is extensible, it is flexible, and we will be able to move fast when new formats change. And to do all this, we need community support. And the way we are encouraging that is by building a community which is neutral and which is inclusive. We welcome all vendors, we welcome all cloud providers, all users who can bring value in any form. And with that, to encouraging furthermore, our commitment is to donate OneTable to ASF. We have made some initial steps, and I'm super excited to announce that OneTable is now open source. You can visit this GitHub website and you can join the effort, bring in your ideas, bring in your use cases, and make it a truly community-driven effort. And to encourage it even furthermore, we have taken already steps to create an Apache incubator proposal with a large set of representative leads from technology companies, vendors, and all. We will be taking this to Apache Foundation. We will grow it with the community, and it will be a vendor-neutral project. And based on the meritocracy of the contributors, people will obviously get promoted into the project. So far, what we have seen based on the activity, the initial committers, this is a small list of what we have, people who have been contributing, but we are super encouraged by the mentors and advocates who have provided support, insights, and have also agreed to continue helping us going forward. This list will keep growing, and with all of us invite you to come and join this effort. It may seem that we have already won the war, but there's a long way to go. Currently, we support conversion from Apache Hudi, Iceberg at Delta Lake. We have tested with many engines, Spark, Trino. You already saw Microsoft Fabric, you saw today, BigQuery, Databricks, Snowflake. There are many engines we have already tested with. We have on-demand incremental conversion for copy and write tables. We also not only convert the latest snapshot, but the change history is also transferred to the new target. But this is just the beginning. There are a lot of good, interesting problems yet to be solved, which includes merge on read, delete vectors, Apache Poimon, which is a new project coming from Alibaba team, that is getting integrated. We are super focused on improving the performance, reducing the footprint of OneTable so that it can live hidden behind in the infra and automatically generate these target table formats. Various deployment modes we want to work on, and also take it more closer to the engine integration as possible. And in the long run, even there are many more exciting features, both for researchers and for industry, where, for example, active writers, synchronized commit timestamps, and so on. I'm super excited, and there are a lot of problems which we want to work with you. I'll welcome you all to join the project. Come and share, contribute, provide us insight. These are various links where you can come and connect with us. Thank you.
All right. Yeah. Thanks everyone for coming out and joining our session. Look forward to the active discussions in the community and hearing how people want to use OneTable in their environments.